Today we're going to work on some radical and complex numbers, just a review for our ACT prep, and we're going to start with a review of the squares. And so you remember maybe back in elementary school when you first start learning 1 times 1 is 1 and 2 times 2 is 4, and you memorize a lot of these, and I think it's good to go back when you're going to take a test like the EOC or the ACT and to make sure that you have all these memorized. So let's just, think in your head for a second. Can you think of 8 times 8, what that equals? Do you know 14 times 14? That might be a little harder one. I highly recommend memorizing these up to 20. So here's the answers. And you can see 18 times 18, 324. 14 times 14, 196. It's really going to help you solve some of the more complex problems if you know these. Also, it's nice to be able to have memorized in reverse. And so here's your square roots. You can take a second, look at these, and see if you know any of these. And so, you think square root of 400 is 20. Here's the answers for those. Square root of 225 is 15, if you can call those to mind quickly. And there's one more little thing that I think we need to note. Before we get into some of the more complex problems, especially when we get the radicals on the denominator and such. It's nice to know when you can get rid of a square root. So you can always do that by multiplying a square root by itself. So the square root of 1 times the square root of 1. If it's a square root and it's squared, then it cancels out. So here's a few more problems you can look at. Square root of 50 times square root of 50. Can you remember what that is? Well, here's our answers for that one. You can see that you just get the number back that's underneath the square root. And so, for x squared being underneath, you get x squared at. That's also helpful in those complex problems. Now, let's move on to the next one. This time, we're going to look at just a few more complicated things before we get into those really detailed problems we were looking at the other day. So the square root of 800, a lot of times they're going to ask you just to simplify. And so for a lot of students, they look at this and say, well, I don't really know what you would do with that. 800 has some factors. If I could find factors that are squared, well, that's exactly what you do. So you can see that 800 is equal to 400 times 2. And you can actually break that apart. You can say the square root of 400 times the square root of 2. And then you can go even further and say that the square root of 400 is 20. And so that ends up being equal to 20 times the square root of 2. Another case to consider is where you have some division. And we'll start with a simpler example where you have a square divided by a square. So here we've got 144, which is the square of 12, and 9, which is the square of 3, and those are divided. Well, you can just go ahead and take the 12 out of the square root and the 9 out of the square root, and you can solve that out as being 12 divided by 3, which is equal to 4. You may also remember that another way to think about this is that you can apply that square root to the top and the square root to the bottom individually. So in this case, we've got the 144, which is a square, and the 9, which is a square, but you don't necessarily have to have a problem that has nice, pretty squares. So in this case, we've got the square root of 144 divided by the square of 18. Well, the square root of 144 comes out to be 12, nice and pretty, but you can't really do anything with the square root of 18. Well, it's not acceptable to leave that square root on the bottom. You can't have one in the denominator, so what do you do to get rid of that? So if you remember, you have 12 divided by the square root of 18. If we could find a way to multiply the square root of 18 by itself, then we would just get 18 on the bottom. That would get rid of our square root and solve our problem. So if you remember, when you want to do that to a fraction, you multiply by the same thing on the top and on the bottom. and that makes it equal to 1. So if I multiply that 12 divided by square root of 18 times square root of 18 over square root of 18, that lets me eliminate the problem.